So, yeah, I've noticed that you took an interest in our work, and I'm curious. Like normally, people that look at it are more. They have a different background, and I'm curious what attracted you to it, or what do you see there? So that was the original trigger for this, and then I'm also very curious to learn more about how you're applying the behavioral science to product design.
Yeah, I mean, again, yeah, so that's pretty much my area. I read a lot of papers, play a lot of video games, think about how it applies to product design, so that way people use the product in a way that makes them get more value out of the product, because the way that I generally see it is that, like, the best a product can do, it really is just make access to the value really readily available, but users usually need to do stuff along the way. So big nerd about that. I don't code myself, so my interest. But that being said, I remember a while ago, a couple years ago, one of the things that got me into gamification was just this idea, like thinking, okay, I wonder if the way that a Microsoft Word is structured could help people write more. Or I wonder if the way that a coding environment is structured could help people code more effectively. Not necessarily in the realm of applying game mechanics, whatever that means to it, but just general interest in how these softwares could be shaped to be more enjoyable, make productivity within it more pleasurable. And yeah, I just kind of like keeping up to date with apps that are taking experimental and interesting approaches to things, and so I don't know all too well what exactly is going on with with your app at this point. I'm actually really excited to see that, but yeah, at this point, basically my understanding is that you guys are doing something really interesting and unique with coding environments, and so I kind of want to see what's going on there.
So, by the way, on the subject of is Word is the shape of Word getting people to write more, for example, or better? There's actually I read recently a study that actually did exactly that. They were measuring kids or young pupils, their ability to write essays, either both on paper and and with some tool like Word, and it turns out that it does affect both not only the length, but also subjective quality. And that's fascinating, right? And it's an interesting thing. But yes, so but this is an old idea in that it comes from Marshall McLuhan, right? This idea that we shape our tools and thereafter our tools shape us. So and that there is this interlink between the two. What's interesting from our perspective is the other way around. So if you notice a behavior that is unwanted, is it possible that it's related to a characteristic of a tool that is not desirable?
Yeah.
Right? And so
the answer is yes.
We're doing. Of course, yes. So at least in our space, right?
Right.
So what is it that we're doing? We are reinventing how people read software. Not how they're writing software, but how they're reading software. So this is one of those subjects that, in fact, nobody talks about. It's not a subject of conversation. So here's something that I literally talked with more than 3,000 people by today, directly, and I asked them, developers, and I asked them, and throughout the world, and all sorts of different kinds of technologies, so nothing specific. And I asked them, do you agree that you spend 50% or more of your time reading code?
Mm-hmm.
They say yes, at least 50% of the time. Most of the time. Most of the people would say yes. And then I asked them another question. So when was the last time you talked about how you read code? So not about the code that you read, but about how you do the reading. And it turns out that they never talk about it. So this is interesting because if you don't talk about something, it's not an explicit subject, right? If it's not explicit, it has never been optimized. Never. And like 50% or more, that's like the single largest expense there is. Because like you can't go, like nothing else can be more expensive than 50%, right? So, and literally today, 50% or more of the development budget gets spent on one single activity nobody talks about. And so that's primarily what we are reinventing. Now, of course, every time you add a new ability, it has repercussions, especially in knowledge work, right? Because especially in software has fractal-like properties, like small things, they bubble up into larger things. So when you add a new kind of a thing, new ability at the core, then it has all sorts of implications that are even broader scale. So yes, it is different what it is that we're doing, and primarily that's what we're doing. And so what do we mean by reading code? So talking about behavior and tools. We know, for example, that if you show people text on slides and you speak the text too, there are interesting studies that show that the retention rate is lower of the audience, is lower than if you either only show or only speak. But you're doing yourself a disservice if you're showing a slide and you're speaking pretty much the text that is on the slide, showing text and speaking about that text. The retention rate is actually lower than if you either speak or show. And yet everybody's doing it. And that's fascinating. Like, why do people do that, right? Now, just think of the default template of, open PowerPoint, say new slide, what happens? Text at the top, bullets at the bottom, right? Yeah. And that's what people do, right? They just, put a text. And nobody puts just one bullet because that looks ugly. So they'll put 3 of them or so, right? And then, it goes like that. There's one other thing, like for example, in Keynote, they had this one, and at some point they didn't have it. I think they introduced it now. Like when you just enter your bullet and bullet and bullet, and then you enter one more, because you're right at the bottom, and you press enter again, and the text becomes smaller, so you can go on. And so this is amazing. Anyway, so
it's like they shouldn't even let you do that because that encourages you to do the wrong thing.
Absolutely the terrible thing, right? It's completely wrong. Okay, but everybody's doing it, and there's a very high correlation between that behavior and the tool that they're exposed to. That's very interesting. Now, if you're into this software world, for example, and you get a developer a problem into a database, there is some problem with data in a database. The first thing a developer would do would write a query, because that's what you do with data. You search data. You never read data. You search through it, right? And they write a query, and they look at the results, and they refine the query, look at the results, maybe they build a visualization or so. And this is how they reason about it. Now, if you give the same developer a problem in code, the developer will start scrolling. Right? And that's a problem because you can look at how the design of the tools that they're exposed to actually mirror on this behavior. So a typical database tool has a big query box at the top, and then the results at the bottom. What do people do? They write queries, they look at the results, they write queries, look at the results. This is effective, and you can work with 1,000 records, or you can work with 100,000 records, or you can 100 million records, and it's the same interface, and it works, it scales. It doesn't matter. It's the way you solve problems does not depend on the size of the data that you're looking at, and it's interesting, right? Now, with code, in fact, code indeed it looks like text, but it's anything like text. It's actually super structured data. all code in the world is very, very structured data, because otherwise it wouldn't be interpretable by the machine, because the machine only knows how to do mechanical things. So it must be superstructured data, because otherwise, yeah, it wouldn't work, right? But people approach it as if it's text, and that's really wrong. But that's exactly mirrors the design of the tool that they're exposed to, which is just a giant text editor. And what do you do when you say text? You start scrolling through it. And so that's the problem. Now, there are some implications there. First of all, systems are much larger than we can read.
Mm-hmm.
Like, it's not unreasonable for a system to even have like 1 million lines of code. If you have to read 1 million lines, let's say you read really fast, 1 line in 2 seconds, and you keep it up for 8 hours a day, it will probably take you somewhere between 3 to 4 months of time to read the whole thing.
And do coders actually do that? Like, oh my god, what a horrible reality to live in.
That's why developers are miserable.
Yeah.
I mean, this is like, no, but I'm not joking. This is like the highest paid, like we get a ton of money as developers, right? In comparison to everything else. Even now, like, I mean, this whole thing that disrupted, a large part of the population has almost no effect on developers. Like, it's just, okay, most of the people were working remote, or many people were working remote in the first place. There's no difference. Like, in our company, there's no difference. Like, before, after, the difference is that we maybe work more now. But, like, really, there's no difference at all. Like, nothing. So this is super privileged class of people. And they are unhappy. Something's, is so wrong. Something's really, really wrong there. And that's exactly it. It's like we are asking them things that are inhumane. It's not made for humans. Like having to reason about billions of details that you have to keep in your head, it's wrong. It's like, this is like what you do. This would be torture. This is what you should be. But it is not something that normal humans can do. And in fact, nobody can. Mm-hmm. And so that's the problem. What you can do, though, is you can augment your abilities.
It's like I'm imagining, I just want to interject here. It's like what I'm kind of imagining here is, I mean, I like to say I study people's behavior at the level of behavior, So it's like experiments with what I can see people doing is kind of like what I like looking at. What I can't imagine doing is looking at a set of neuroscience studies, understanding how all of the different neurons interact with each other, and then trying to piece all that together into a coherent narrative of people's behavior. And to me, that's kind of what reading through millions of lines of code to try to understand how a program works,
You're precisely, it is exactly what is going on. Mm-hmm. Like it's like asking an architect, somebody to architect the city, and the only tool you give it is it's a magnifier glass. Right?
Yeah.
It's like, it doesn't make absolutely any sense. Like you get super details on every single line of code. The only problem is you see 50 lines at a time.
The whole point of this stuff is that it's supposed to, like, all these individual lines of code, they're all supposed to piece together into abstractions that we can understand. So why not operate at the level of those abstractions instead of at the individual pieces?
That's one. But the other thing is that code is data.
Mm-hmm.
And then, so for example, there's this, I just saw a beautiful story today in New York Times about an argument talking about why Manhattan should be mostly car free. But like, the story is amazing, right? But it puts a ton of information in it, and you almost see no numbers. It's not about graphs. It's highly emotional, but you have real data in there or real input, and it's really, really beautiful. And that's what we mean, right? You were talking about narratives. We actually think that, in fact, we make sense of anything through narratives. So what we see Glamorous Toolkit be, first thing, is basically it's like a platform for creating narratives about the inside of software systems. Right? And then you look at it completely differently. It's just totally different. The first thing you see is not a text editor. Um, you search first, you visualize first, you edit after you know what, you edit after you know why, and not before. It's not the first thing you start from. So then, once you start looking at it like that, then it's all turned upside down. And then there's one more other thing. The reason developers or people read code is because they want to understand enough to make a decision. Right? That's decision making. It's not, they don't read it like you would read an astrophysics book or, I don't know, Harry Potter or something like that. They read it with a very specific intent of knowing what to do next. So we look at the whole business of software engineering as being not a construction business, but being a decision-making business. And then again, like whenever you shift the perspective, you see completely different things that other people don't, because they just look at it like that, and you don't look at it from the side. And yeah, so we have our view on what software engineering should be like, and the experience of developing systems is completely different.
Wow.
But I can show you a little bit. If
I would love that. Yeah.
Okay, let me show you. So, so here's okay. So it looks like this. The environment looks like this. You open it up, and you get a bunch of some sections here. So, and then here is our blog. Okay, at the beginning there's some pop-ups that prompt you to things like take the tour or see our blog posts, or register to our blog feed. So you get this feed of the environment, or about the environment, right into the IDE, right? So if I click on that, eventually, so now what happens is it connects to the net and then downloads this one, and this is now this is a live document that happens, or that takes place directly into our environment, and this is actually a live thing. I can go and modify it here, so I can start typing in it. And what's interesting about it is, again, like this is a new kind of an interaction ability. It's a new kind of an editor that is both. It looks like what you see is what you get, like a finished thing, but it's actually editable only when you start editing. So it's a different, like there's no friction there about this. Now, what is interesting about this blog, because like blogs are not so interesting, but what is interesting about this one is that we created this specific document. I created it inside the environment, and I published the blog post from the environment. So the idea here is, and this is just the beginning of it, but the idea here is that we start the conversation, we author the narrative, and we consume the narrative in the same environment. Because that's what the I in IDEA stands for. It stands for integrating. And that means that everything about a system should be integrated there. And every time you leave, or you have to leave, or you feel like you need to leave because there's some value somewhere else, it means that the I in IDE has failed. That's my understanding of that design goal. So, and so what you see here, basically, this is a piece of document that anybody can read. Like you can read it, and you could still get something out of it, because there's nothing. It doesn't have to be technical, right? It's just it just looks like a document, like you wouldn't read on the web. Yeah. But you're literally in the development environment, and that means that we can start telling stories and having people consume those stories in this integrated world. Now, let's take it a step further. So this is actually about an application that, does face recognition by looking at some, like taking a picture and then talking with the API from Microsoft, and then doing face detection. So if I'm now, you see here, I see GTCS picture. This is the name of a class. If I'm looking at that one, so now this is a class, right? So do you know how to program a bit, or I don't know?
Not really. No.
Not really. So class is a specific. It's like a concept, right? It's like a noun in terms of you need nouns and you need verbs to formulate sentences, and that's basically how you instruct the computer, right? And so what you see here is that I'm looking at this is not a typical thing. So here you would see code, for example, things like that, right? That kind of things. Okay, so I can do kinds of funny things. I can look inside that code and it just unfolds in place. And this is a live editor. I can do things here. But what's interesting is actually that if I turn to this comment, right? The comment is that live thing, and here it says, "Oh, here's a snippet, and I can run it." In this case, it shows me nothing because I didn't do some other things. So basically, it's like a tutorial of sorts. So here it detected some pieces, and this is a technical documentation, essentially, if you want, about this. And now, if I inspect this one and I move it on the right, I can start looking at it, right? I took something that's highly technical, but now here on the right, I see something that the end user might relate to. But notice how there's no this distinction. There's no more, this is what the user sees, this is what the technical person sees, right? And then we complain, that business people and technical people, they can't talk to one another, right? But we always show them completely different things, right? And then we notice that their world have a difficulty of coming together. So that's kind of wrong, right? So if you're integrating, then what about integrating the whole continuum? So anyway, that's the idea there, right? So here, for example, I can see there's a picture with 3 faces detected, and if I click on this picture, right, or on that one, or on this one, then I can look inside there, or I can maybe just see the landmarks, the specific things, or the drawing of it, or so. So I can see how those things are composed. Make sense?
Yeah.
So basically, normally, in normal environments, these are objects. They look like this. Some variables and values, some variables and values. This is how a normal development environment would look like. In fact, they would just show you one at a time. So just this. Right? It would even show this one, right? And then by changing and allowing people to add new projections onto these things, you make it immediately more humane because you can start to relate to it.
Yeah.
So let's apply this one to a domain. So here is the domain of a restaurant automation. Okay, so you go to a restaurant and there's a waiter that comes there. You place an order. You want a steak, and then the waiter then sends the order to the cook, and the cook cooks it. And then after a while, the cook tells the waiter, "Please come and pick it up." And then the waiter comes and picks it up, and so on. Right?
Right. Yeah.
Okay, that's the domain. So this one is an interesting thing because it turns out that this is a difficult domain. So if you look at the market share of the largest restaurant automation systems, in most countries, you have the leader has like a 1-digit market share. So it's super highly fragmented because people are looking at this problem as if it would be a configuration problem. So it turns out that all restaurants look very much the same, but they're very, very different. So their workflows are different, and there's a lot of variation there. And the question is, how do you capture this kinds of a variation? So we looked at this problem as slightly a different thing. We looked at it as if it's a programming language problem. So we said, can we create like a programming language for the restaurant? So here it is. So let's say I have here something that I call a cozy corner, which is a venue. And the cozy corner has 2 areas inside, which is a kitchen and a room, right? You see, I have a new area here, and then a kitchen. And then this kitchen is in the cozy corner. Yeah. The kitchen is in the cozy corner, right?
Mm-hmm.
And then in the room, there is a table 1 and table 2.
Mm-hmm.
And then there is a John waiter, which is a contributor, which is associated with table 1 and table 2. Right?
Okay.
Can you kind of form that mental model? Right? Okay. What about now?
That's cool.
Isn't it easier?
Much easier now.
Right? It's like you can't it's like in the first one you could do it if you focused.
Yeah.
It took a while, but the second one is like boom, here it is, right? I don't spend any mental cycle to reason about something that is rather obvious, in fact. Now, it turns out that we drew this kind of picture on the whiteboard before, right? When we were talking, brainstorming about what the system will be in the future, we drew something on the whiteboard. Very often people draw something on the whiteboard, right?
Yeah.
On a napkin, on the whiteboard, somewhere. Those are representations of thought that have value because they communicate, they instill in some other brain something that I want to communicate. Now, whenever we have a representation like that, we say it is the responsibility of the system to carry it forward. That's it. The system should tell that it's a narrative. The system should present that narrative. Okay, now, we said we want this one, like these are little pieces that do things.
Wait, so one thing I'm curious about here is, I mean, I think so far what I'm understanding essentially is that when you input this information into your code, like this is what the code is essentially understanding and acting on, so you might as well visualize it. Right?
Yes, exactly. But it's the other way around, right? So this is not this view here. If I take it out, the system still continues to run.
Right.
This view is just a projection, like a data science visualization. It's just some other view. Like if you open Excel and you have a table, and then next to it you say, "Oh, let's show it as a chart."
Yeah.
Right. So now you have two views, but the table is the essential one. The chart is not essential. You can delete this chart and put another one, or don't put anything, and it still continues to function properly. Right. But again, like as I said, like we're reinvent. Our focus is on reinventing how we read a piece of the inside of software systems. So and there's this lens of translation that is important.
So I'm curious, like how often you think that this meaning is shared between the user and your system. You know, because like,
and that's a very good question. Very good question. And that's why we have invented a new way of programming in the end, which we call moldable development. And that is, if I feel that like that difference that you felt when you squinted on the left-hand side, when you started to look at the right, you say, oh, yeah, now it's, you see, there was like a moment where you would just, oh, it just got, you felt a relaxation in your brain. When I feel like my brain is not relaxed, it means that I don't have a good view. So I will stop and build a view that works for me. Whether it works for you or not, it doesn't matter, because it is enough for it to work for me. And this is the difference. In fact, it's not the tool. The tool just makes all these views easier to host and cheaper to write or create. But at the end of the day, what we are modifying is that one. That if I will just look for the moment, if I feel like I'm not enjoying working on a bug, it's a tool problem. And I will change the tool until I feel pleasure working on that bug. Okay. And we do this all the time. And we have thousands of views for a system. Right? So the first thing, as I said, I want to create a programming language. And now it means that all these little boxes, they're like, actors. And now we need to empower these actors with some abilities. So I have here these scripts here on the left. And so now if I execute those, notice how these act. Like Jeff Cook has some ability here that when something acts like this, right? Simple logic. Like you were talking about games, so it's kind of like that, right? It's like little actors that are all, independently doing something. They have like a state machine, and now we empower them. And now what we want is to go and say, what happens when your John Waiter comes with you at table 2, table 1, and you're there, and then you say, I want a steak. And then John Waiter has to place that order, right? So here it is, and I'm not going to explain how that one works, but this is what happens with the order. So John Waiter just placed it there. John Waiter doesn't know about the rest of the restaurant. It only knows about table 1. It doesn't care how the kitchen is organized. It doesn't care who's at the kitchen. It doesn't care whether there is somebody at the kitchen at all. Now, or maybe they will come in 5 minutes. It doesn't need to know all this information for him to just take the order and place the order. So what happens here is exactly this is what we are visualizing here. It's a way of propagating messages throughout the environment in a way that John Waiter can communicate with Jeff Cook without them knowing of each other and without their abilities depending on each other. So what's interesting about this, there's all sorts of flexibility that comes in. It means that, for example, the shift on the kitchen can change anytime independently of the shift of the waiters, for example. There's no dependency between them. They're still able to communicate. So there are all sorts of things like that. Other things what just happened here, like is a message that went all the way to the restaurant, and here it was transformed into another message, another order, basically, because maybe the restaurant did some other things. Such as, I don't know, put it in the accounting or stuff like that. Okay, so that's what happened here. And now what happened is that Jeff Cook has to cook the food, and then of course he has a to-do here on the to-do list, right? And after a while he says, "Okay, I'm done," and then he says, "I'm done." So then he says somebody has to come and pick it up, and then of course now John Waiter has a night on the to-do. Right? And then he has to go and do stuff. And so what's interesting here is that this kind of thing is what happens now, because now we have modeled a classical restaurant. But, nowadays I also have one of these. So if I have a phone, why can I not come in and then, here's Alice Guest that comes into the restaurant and hooks into the restaurant. And now she can place the order directly, because what if the menu is already digital? And then she can place the order. What happens there? So what happens there is that she places the order, and the order goes to Jeff Cook, and the Jeff Cook doesn't need to know where the order came from. And the only thing that I modified in this graph is really that you just added new Alice Guest in there, and everybody else remained exactly the same. So now when Jeff Cook has to go and says somebody should go and somebody should come and deliver this, what's going to happen here is that this order will go to John Waiter, because that's the rule of the restaurant. You can order, but the server will come and give you this and deliver the food. This is just the way this restaurant works. Other restaurant might be self-service, and then this notion will go directly to Alice Guest. But what I just
something this is almost here, making me... Oh, sorry. Say what you were saying.
Go ahead. No, go ahead.
Something this is almost making me wish I could do, is I kind of wish I could do this in reverse, instead of starting from code, starting kind of from these visualizations and using this as a way to do systems mapping for myself, so that way I'm able to ask myself, okay, I plug in this input and I see how this propagates throughout the system. Because at this point, what I might do is draw out a bunch of these sorts of connections and stuff. But then it's still kind of hard just to mentally model, okay, I add in this one input, now what happens? So I kind of
happens, exactly.
Yeah, so I think this is super interesting. I wish that mind mapping software, and systems modeling, do you know Kumu?
No, I don't know.
It just lets you kind of draw, this connects to this connects to this, and draw out systems that way, but yeah, this just seems like a neater way to do it. But I probably just need to learn code to do that, and end up with a computational model of my system. But yeah,
right. But so there is a continuum. So here's the interesting thing. You probably understood what I just showed you, right?
Mm-hmm.
Now, I gave you a demo, but this demo described an algorithm.
Yeah.
It didn't describe a user interface, right? So, for example, a user interface would be this one, which says how the invoice would look like, right? So it says now, there are two sirloin steaks, and now I have to go, John Waiter has to go and create an invoice for probably one of them, and then puts it there, and then you see here's the VAT, and and then you create an invoice out of this, right? That's a user interface that a user might end up seeing. A user will never see these lines because it's not something a user sees. But you could understand what I just showed you in minutes
Mm-hmm.
And you have just seen the inside, the core behavior of a software system.
Yeah.
You have never seen the story about software systems like that. And we
Mm-hmm.
can tell thousands of those kinds of stories. We already have them. And we can tell them with various different kinds of levels of abstractions. Of course, because the audiences can be different, right? Now imagine this is actually work that we did with a startup, and this was actually a pitch that we did for investors,
Mm-hmm.
right? And so what is interesting there is that when you can, like, we don't have to build the whole app to convey what our system is. We get this feedback loop at a much sooner. We're talking about probably an order of magnitude sooner, even if you use super rapid prototyping things. And the level of granularity at which you can get those kinds of feedback loops is very much shorter.
Mm-hmm.
And so that's basically the difference. That's kind of like a gist of what it is that we're doing. And so what you're looking at here is literally what you should be looking at. What more developers look at is this. That's what they see.
And then they have to
them.
piece those connections together.
They have to put them in their mind, and they cringe all the time because it's really it's uncomfortable, and it's not human. It's not humane. So that's the kind of thing. And there's a whole lot of stuff that comes out of that, right? But notice how I basically told you a couple of stories from inside my environment, and I never left. Right? I never used any other utility for me to convey even an emotional story, about something that is computation related. And so we think that's what it is that we're doing.
Well, one thing that occurs to me with this is that, like a lot of people, like one thing I hear is people saying like, okay, commenting your code, that's incredibly important to do, makes it more readable, right? But at the end of the day, those comments usually end up just looking like grayed out text, which is naturally de-emphasized, and really that's the best representation you get of it. And so I wonder to what degree people being unwilling to comment, spend the time to comment their code and to really like think through how their future self will visualize it. I wonder to what degree that is just because there's not a good way to visualize that in the future. Like at the end of how useful.
Precisely. Yeah. So like, for example, let's say I showed you now this one. Let's look at the documentation of the system, right? Not of this is how the documentation then looks like. So if I want to look at the specific demo that I showed you, I got this one, and I have now here a new document, right? And then in this document, I have narrative now. And then, okay, this is also live, so I can go and do those things and all stuff. Right? So this is a live piece of document. But there are other things, like, for example, here's an example about, how do I compose prices?
That example you just showed right there, the one before this one, I'm just imagining how much more valuable a company would perceive the coder if that coder is able to make these sorts of visualizations for that company. Because a lot of this, the role is probably in communicating what your code does. In this right there, that's a great communication of it.
Absolutely. In fact, in many companies today, even if everybody is a software company, but even today, software is perceived as a cost, not as an investment. Right? And that's very often because, and it's also perceived as a black box. Like, there's a very high, every time you're going to invest something in that piece of software, whether it's more people, rewrite, new technology, blah, 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 move to the cloud, all of those, they're all done. All those decisions are done on the premise that this is pretty much a black box that you have very, very, very few people even there looking into, and even fewer of them understand anything. So this is like, it's really, really like, yes, it's true. Like, that's exactly it, right? You change the you change how something inside can look like on the outside, whole sorts of new energies are now basically being moved into a new domain. Right? So yeah, that's exactly it, right? And I was just saying, here's, for example, something with prices. So prices is a domain, like you would say, this is like accounting. You know? So here's how I represent it. You see, here's a piece of code, and I can execute it, and I can see the result there. But let's take something that is more maybe complicated. So here I have an example of a price, which is like 100 euros of a concrete, which is a concrete price, on which I discount by money, add a discount by money of 10 euros. So I get 90 euros. And then on top of that, I get a discount by percentage of 10%. So I get 81 euros at the end, right? But this is literally, I'm just, so if I, so here, if I actually just show the whole thing, let me show it here on the right. This is what normally people see, right? This is like a price discounted by percentage, blah, blah, blah. And if I look at it like this, boom, you'll think differently. And then again, how did we draw this one? Is because we talked with people and then they drew it like that. They said, we want it to be shown like this. I said, fine, this is how it will be shown. And people are doing this all the time. It's just that these environments are not making that, right? And then we just change the property of the environment. And as you notice, right, it enables whole new level of, wow, we can extract value in whole new ways. It was just never possible before. Mm-hmm. So the behavior is the interesting thing, not the technology. The technology is just there. It's interesting only to the extent it enables a new behavior, but that's it. So, yeah.
Yeah, this is super cool. Something you said in there that was really interesting is that you were like, okay, what's really important is the behavior, and how, in the degree the tool is useful is the degree to which it allows and enables that behavior. So I'm curious, what are the behaviors that someone needs to do to really make Glamorous Toolkit an awesome thing for them?
So the reason we call it Glamorous Toolkit is, first of all, you don't get many chances to call something glamorous. But the reason we call it like that is because programming is the coolest job on the planet, and it should feel like that. So every time it doesn't feel like that, it's the fault. It's on the developer side. It has nothing to do with the problem. Mm-hmm. So and what we're doing with Glamorous Toolkit is that if you feel terrible, stop and don't feel terrible, and then you go and do your work. So that's the behavior that we want to change. Today, even if they do feel terrible in any other environment, they are not able to modify anything. They can't affect their feeling. They can only affect the problem, or the system that they are building. But they can't affect how they are building it. They can't affect how they are seeing what they are building, and that's a problem, right? And that's the behavior that we want to change. We literally want, so all of these views, all of them, right? So here's a simpler view, just a tree with which just says how this thing was constructed, right? Mm-hmm. So let's see how is this one being. If I now click on it, this is the code. This code here is the code that produced this view. So let me show you here. If I say children 2 and I save it, it changed this view. I modified it live, right? So every time I look at something, I say, oh, I don't really like how it looks. Oh, let me go and modify how it looks, and then I come back and I work with it. Mm-hmm. Right? So it's this, yeah.
So you want them to essentially notice their moments of frustration with handling a bunch of code that's hard to just abstract from. So you want them to, one, notice those situations, and then two, go in and build a visualization that's going to be good for them.
Yeah. Yes. And this fundamentally changes how you program. You're not going to program in the same way ever again afterwards. Mm-hmm. It's not comparable. And we're talking about improvement in both happiness. I smile all the time. It's really.
I can tell you seem like a smiley dude.
And but second is you get economical gains, and we can talk about significant improvements in productivity.
Mm-hmm. Mm-hmm. Okay.
So
they have significant improvements to productivity, and they also just feel better.
Much better. You're gonna your brain. You're gonna solve problems. Look, when there are all this work around emotional design, right?
Mm-hmm.
So like people being presented with one kind of one same functionality being presented with two interfaces, one looking ugly, one looking beautiful by some measure, and having people that are exposed to the beautiful interface solve the problem better than those that are exposed to the ugly interface. Same problem, same machinery, just that the interface is different.
Yeah.
There's so much power in the shape of how data and computation looks like, in how we can address it and fix it or make decisions about it and relate to it.
Mm-hmm.
That has never been, like, up to now, all IDEs in the world, regardless of which system you're looking at, they're all going to look exactly the same. Just think of all the cliches about how a developer screen looks like. They're all looking the same. Like all these big things, giant text editor. Like here, I showed you 3-4 different kinds of things I was looking at, and all of them were looking differently.
Mm-hmm.
This is not a small change. It's not cosmetics. It just completely changes what happens in your brain. Just like with just that tiny change of how Rome, for example, right, said, "Ooh, here's the structure that we inferred." Right? The only thing they did, they didn't add content. They only showed the content in a different way.
Right.
And in their case, it's hard coded, as you notice, and you notice that it's already too tight, right? You would like it to be more flexible so that you can build the language that basically transforms the data into the presentation that you would like to see. You want to be able to control that. That's what we call moldable, right? The environment has to be moldable. And it's the only way in which my brain can relate to computation or to data.
Mm-hmm. Mm-hmm. Yeah, no, that sounds really interesting. I'm like, and I think to explain this to me, someone who's very not technical with code, like I think that's a good sign, that because it sounds like that visualization to anybody is very important to the vision. It reminds me of how like Figma. I think Kevin Kwok had an article recently about Figma where he was like, one of the main things that Figma did was that it made it so designers could talk with non-designers and have them all kind of play this role, and have a seat at the table together. So I think that's super cool. I think it seems like it has benefits to the individual person. I'm 100% on board with this idea that that different UXs for this stuff can, in different visuals and just prettiness, I think that absolutely has an impact on stuff. But it seems like you're not just changing the aesthetics; it's a functional aesthetic change.
It is, yeah.
Which I think is much more powerful, even.
Mm-hmm. So, okay, let me just say. So let's say I want now I just want to tell you. I'll share the screen again. I want to tell you how much of this is like, because I now showed you a demo, right? And I showed you 2-3 things. Maybe this is just, it works for these demos, right? Maybe it's not really something that is so fundamental. If it would be fundamental, it would be everywhere. We would be using it everywhere, right? And because why, building demos has maybe some incentive for me because maybe I'm looking for investors, maybe I'm looking for users, maybe like something. So I might have an invested reason to actually add extra effort and do something that is not actually valuable for me, but is valuable for other reasons, right? But when I do things that others don't see, then that tells a completely different story. So what I'm doing now here, like as I said here, right? I said this thing over here is what defines this view on the left, right? And you can see it's a column tree, and it has 2 columns and blah, 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 right? And these are the children, the items. It's not actually that difficult to, like, if you read it, but you shouldn't read it though. But what is interesting, there's this green thing here, this green thing, this GT view here, right? It's there. You see it?
Yeah.
Okay. So what I will do now is I say I want to find all those green GT view things. So I'm now running this. This is now a query, and I'm running it over my system, and now I get a bunch of these, right? And I can see it there. I can see it there. I can see it there. Right? There are many of those. Right? I can see them. Okay, now let's see how many there are. So now I'm switching. This is a filter. And you see here, there are 931 of those. In this system that I'm showing you, there are 931 different specifications of tabs. Okay, and the average line here per method, it's 12 lines of code. And this is essential, right? In order for this thing to economically work, right? The friction to go to, oh, I really would like that, to actually getting it, it must be almost zero. It has to be measured. In our case, it has to be measurable in minutes. And that line there shows exactly that. That's the science of what it is. There's a science behind this. So there's a whole theory that we built, and it works. We built the whole system like that. So just to maybe just convey it also slightly differently. So there's whenever you're starting with Glamorous Toolkit, and it invites you to go and watch a little, like a slideshow, because that's a different way of giving, telling stories, right? So here I was just saying, this is a story. These are 6 different objects, right? 6 objects. And all of those, they look the same, and you can't squint away. You have no idea what they are. And if I change their shape, then boom, you think of them differently. Like, this is a fraction. You don't have to know much. This is a folder. This looks like some picture. This is like a Bezier curve, and right? Just they feel different. And so you know how to compartmentalize differently.
Yeah.
But what I wanted to show you here is this visualization. So this visualization basically shows you, this is the whole system, the whole Glamorous Toolkit itself. And all of those that have blue have at least one custom view. And all of those that are green are actually examples. And we didn't talk about those, but yeah. So essentially, this concept that we're creating are needed throughout. They're pervasive. Their need is everywhere. Everybody needs them all the time. And we have built this system is built like that. Just for example, how Rome research is documented in Rome research, right? So, or the to-dos that they are following, they are documenting in them the same in the tool that they are building. And so that's basically the actual proof that it works. There are a few others anyway.
I think it's really interesting that these sorts of visualizations are the sorts of things where, like, on average it takes around like 12 lines, because I mean, again, I'm not a coder, but I imagine for coders 12 lines of code is pretty trivial. Like, that's basically nothing for them. They'll pop that out in a minute, especially once they get fluent with the way that these visualizations work. So I think that's super cool. I'm really, I think one thing that I would think about a lot, with regards to this, is just that behavior we identified earlier of, like, okay, how can we help the user to recognize the moments where they're struggling and, like, when they're frustrated, and how can and then also, like, how do we get them in that moment to recognize the next step is to make a visualization, reducing the friction to making the visualization and making it like these 12 lines of code. I think that's super helpful towards that. But
that's absolutely not enough, because what you said, right? How do you get them? Because their default, they already have a default action.
Right.
They've already had it. That's why they go back to reading code, because that's the most flexible thing they have. They can read anything. The only problem is that they read very slow. So it looks, from their perspective, reading the next line of code is progress. Right? So they're incentivized. The incentive is right there. The question is, this is not an answer question, by the way, and you're correct. We don't yet have the massive, like, we don't know how to communicate this. We knew how to build it.
Right.
Now it's there. The big challenge, the real challenge, is how do we communicate this in a way that that affects, I don't know, 1 million developers. Like, again, and it has nothing to do with whether they're going to use Glamorous Toolkit or not. It's inevitable that all other tools will look like this in the future. It's inevitable. There's no doubt about that. Still, the question is, how do you incentivize and how do you change the behavior? And that's not clear yet.